Unit 4A, multiplying rational expressions. Problem number 1. You got this expression multiplied by another expression. The coefficients are multiplied. Multiply 5 times 2. 5 times 2 will give you 10. Powers are added. Powers are added. 5 times 2 was 10 here. X to the 5th times x to the 4th is x to the 9th. Y to the what? Y to the 3rd? Because it's 1 plus 2 is 3. Numbers at the bottom are multiplied. 3 times 4. 3 times 4 is 12. X times x, x squared. Y squared times y, y to the 3rd. Reduce the numbers here. What's the biggest number that divides into 10 and 12? What's the biggest number that divides evenly into 10 and 12? That would be 2. So 10 divided by 2 is 5. 12 divided by 2 is 6. Where are there more x's? At the top or at the bottom? Where are there more x's? At the top or at the bottom? At the top. Automatically you put it at the top, the x. How many more x's at the top compared to the bottom? Or if you want to do it mathematically, it would just be x 9 minus 2. X, what's 9 minus 2 is 7. So x to the 7th power. What's going to happen with the y's? Cancel out. So that is the answer right there. All right, problem number 2. Continue. Let's continue on with number 2. No, we're not going to multiply this out. All right. X minus 4 is what? Whenever I ask something like that, what is x minus 4? It's a factor. It's a set. Here's the problem you guys have, and I'm just looking at what I didn't put in this lesson, is that people do this. Watch. This is what some people do when it comes to fractions. People do this. Oh, look at that. That is absolutely wrong. People go, look, an x and an x cancel out. No, 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 no. This is a set. This is indestructible. Do you guys know an atom? No, actually, I thought they were saying that an atom was indestructible, but actually you can destroy it or break it down some more. In any case, x minus 4 is a set. It's one thing. It's together. One thing. All right. It's all right. So in the top, we can do the x method of factoring and getting two sets. Do you guys remember how to factor this? My way, middle number to the bottom, 5, and then 1 times 6 is 6. What are two numbers that multiply to 6 add up to 5? Is that 3 times 2? Is this 3 times 2? 3 times 2, 6. 3 plus 2, 5. Childish. No, let's stop doing that. Can we go directly to the factors here for this one? It's definitely going to be x and x. X and x. What are the two numbers? Oh no, we need the x. Oh, this class needs the x. Figure it out. It's 5 plus 3. I gotta get going. Nobody said it. 5 times 3 is 15. Yes. 5x and 3x is 8x. Yes. That's called a difference of squares. let's play high school math now. Let's not be child. What's that? What's the answer to that? That's the difference of squares. Let's go. X plus 4x minus 4. Okay. Let's go. Let's go. All right. Here. Why did I even do this? Let me erase this and let me do it like we're in high school, and not and like a root x and x is gonna be what 6? Is that, did I say 3 and 2? Yep, 3 and 2. 3 and 2. 3 times 2 6. 3x plus 5x. Yes. What can we do now? Let's go ahead and draw a big fraction line. And what can we do here? What can we cancel out? I got 29 people in here, I think, or less. Can somebody? What can we cancel out? Can I cancel out an x minus 4 with an x minus 4? What else can I do? Can I cancel out an x plus 3 with an x plus 3? What else can I do? That's it, no? Yes? So then this is going to be what? Left over on top will be what? X plus 2 and x plus 4. And at the bottom, x plus 5. And that is the answer to this. Like I just said, I am recording this lesson, and too bad not a lot of people go watch my videos, but you can go watch at your own pace, and figure that out. Let's go. Number 3. All right, dividing rational expressions. So, I don't know, is it a thing still about dividing fractions? Let's see, what did your teacher teach you when they said 2/3 divided by, say, another fraction, 1/4? What did your teacher teach you? Did your teacher said something like, keep the first, leave it alone the way it is? Reciprocal is the mathematical word for it, but flip the second and multiply. So that will be 2 times 4 is 8 over 3. That is the procedure or the method. I don't know what they teach nowadays, but that's the way I learned it. All right. So I'm going to do the same procedure here. Keep the first, flip the second, and multiply. It's the same problem we did in problem number 1. Same kind of procedure. 4 times 2. 4 times 2 is 8x. 3 times, there's no number here, there's a 1. 3 times 1 is 3. Powers are added, x to the what? 9th. And there's nothing that goes evenly into 8 and 3, so I'm going to leave that alone, 8 over 3. Where are there more x's, at the top or at the bottom? At the bottom. So you automatically put x at the bottom where there's more x's. How many more x's at the bottom compared to the top? That's the way I look at it. There's 8 more and we're done. There's other ways of looking at it, but that's just the way I look at it. Yeah, let's go. That's the answer. We're going. Okay, here. Let's go. Number 4. Okay, this is how I'm going to do it. Draw a big old line. Let's see. Have it prepped. What is x plus 3? Can you say factor? Can you say set? My own personal one is a set, and but it's a factor. X plus 3 is a factor. Leave it alone. X plus 3, bring it down. There's nothing you can do to a set. That's just a set. It's a factor. Let's go ahead and factor out the bottom here. This is going to be x and x. And then what are the numbers? It's got to be something like 3 and 4. It has to be 3 and 4. Or 4 and 3, 3 and 4. Which one is negative, though? One is negative, one is positive. Yes. We got to get going with this. Let's grow up a little bit. And that's why those people over there that I told you guys didn't want me to teach, because they're like, why are you doing so childish? Teach. Let's go. What's the top one called? Difference of squares. Yes, don't everybody say it. Difference of squares. So what would it be? What's the difference? What would it be? X plus 1 and x minus 1. Where should it go? I'm already going to do that. Yes or no? Can I already do that flip? So it's going to be what? X. I'm going to put it here. X plus 1, x minus 1. See, now we're doing big kid math now. In a big kid way. Let me find out what are the factors of that. What is it? Can we go here and then I'll just put it on top? It'll be what? X and x. It'll be what? Is that 4 and 3? Yes? That's going to go to the top, no? So that thing became this thing. Then now what can we do? Can we just cancel the x plus 4 and x plus 4? Can we? Oh, man. Can I cancel x plus 3 and x plus 3? It's a trick question. You're supposed to say no. It has to be one at the top, one at the bottom. So what am I going to put down on top then? X plus 3 what? Squared. And what do I put at the bottom? X minus 3 times x plus 1, x minus 1. Adding rational. Continue. Let's go. It's math on steroids right now. When we add fractions, what is the most important thing when we add fractions? Common denominator. Common denominator. Do we have a common denominator here? Yeah, I mean, how obvious do I have it? Like, this is the same as the other common denominator. Okay, so put it under one of them. Now, what's the answer at the top?
6.
What did you say? What's the answer at the top? Oh yeah, it is 6y. We're supposed to add. So 1 plus 5 is 6y. Yes. I thought something else. I was thinking something else. Something wrong with me. Oh, what else do we do? What else can we do here? Can we reduce this? 6 divided by 3. Can I just go 6 divided by 3 is what? 6 divided by 3 is 2. Where are there more y's? At the top or at the bottom? Where? At the bottom? How many more at the bottom compared to the top? That's the way I look. Can we just... Yes? Yes, keep going, keep going. Let's go. We're adding these fractions, these expressions. Do we have a common denominator? Yes. So if we have a common denominator, what must I do? Sounds weird what I say. I say put it under one of them. I was like, what do I mean by what I say? I don't know. Like, like do this. Now what's the answer to the top? That's the problem. What's the answer to the top? X plus 4? It is x plus 4. It's x plus 4. Now the bottom, let's continue on. What is the bottom called? Difference of squares. And so what I put down right here? X plus 4x minus 4. And then put the x plus 4 on top. And I can cancel out a set with a set. So cancel out what? This, and the answer is what? What's the answer? 1 over x minus 4. Yeah, that's what people are like, what x minus, no. It's 1 over x minus 4. Let me give you 4 minutes. Do it by yourself. You do it by yourself. 4 minutes. Do we have a common denominator? Yes or no? Yes or no? Yes? Put it on there, one of them. See, I already see people getting to this point. So we're going to add like terms on top. The highest power is m squared. Nothing to add with m squared. How about 8m and 4m? That's going to be what? 12m. My writing is getting messed up. 30 plus 5 is 35. People are over here like, what do I do now? Do I cancel this m and this m and then? What is m plus 5? It's a set. It's a factor. And what are we going to do on top? Can we directly, quickly are able to do m and m? Is it factorable? Maybe is it 7 and 5? Is it 7 and 5? Yes or no? What now? That's the answer. It's just a puzzle. But they're all that I'm giving you, most likely it's going to be factorable. Let's go. Number 8, let's go. Let's do it together. The question to this is, do we have a common denominator? Do we have a common denominator? And the answer is no. So let's make it common. How do we make it common denominator? First of all, let's break it down a little bit. Can I break down 5x squared minus 125? I'm looking at this only, right here, the denominator here. Is there a GCF? What's the GCF? 5, thank you, 5. If you factor out of 5, what's left over? Minus what? 25? Ah, do you notice what's going to happen there? Don't you see it? What is it? Difference of squares. Math just becomes like, well, okay, just over and over. I get it. That's if you get it. What's the difference of squares? I don't know. What's the GCF over there? 3? You know what I mean, GCF? 3, and then what's left over inside? X plus 5. All right. We're going to do this. It's like when I used to collect baseball cards when I was little. I used to be like, hey, I have this baseball card. Do you have that one? And we matching up cards and whatever. And like, okay. So basically what we're going to do here is we're going to match up. We want this, have a common denominator. All right. For sure, we already got this matching up. All right? Yes, we do. So now, what is here that is missing over there? For sure, it's missing a 5. Yes or no, everybody? What you do at the bottom, you do at the top. Yes or no? What else is it missing? What is the second fraction missing in the denominator that the first one has? Can you guys all say x minus 5? Yes, yes. Now, that one has a little extra that this doesn't have. Now, let's go back. What does the second fraction denominator have that the first one is missing? Somebody say it loud. 3. 3. Yes? Now, let's go ahead and just run it under one common denominator. Let's go 3 times 5 is 15 here. Then we got x plus 5, x minus 5. This is what? What is this? 21x? Can we quickly go over here? 4 times 5, what's 4 times 5? Do this. 4 times 5 is 20. And then I'm going to distribute that 20, yes? Yes? So what is 20 times x? 20x. And what is 20 times negative 5? Negative 100. Finally, the answer to this is 21x plus 20x. 21x plus 20x. 41x minus 100 over this 15 x plus 5, x minus 5. And we cannot do anything else here. That is not factorable, and that is the final answer. All right, I think we have a subtract one here. Let's go, continue, subtract. when you add fractions, you subtract fractions. The main thing, most important thing is that you have a common denominator. So now, do we have a common denominator here? And the answer is no. So now, what do I do? You multiply the 5. What you do at the bottom, you do at the top. So now I have a common denominator, put it under one of them. That's kind of what I say. And then 5 times 3 is 15. 15 minus 4 is 11. Let's go. Number 11. Am I gonna just? Should we do this test on Wednesday? No, was it? Yeah, Wednesday. Should we do the test on Wednesday? Let's see. Yeah, why not? We got 23. Finish the lesson. Do we have a common denominator? And the answer is yes. So we're gonna put it under one of them, whatever that means. 2x plus 2. Bring this down. You're distributing this minus sign. Here's where people, can we just kind of distribute that minus sign, meaning that this is going to become negative, or 2x squared, and this one is going to become what? Positive 2x. Is that okay? You want me to? Is that okay? This can become positive 2x. Or see, this is where people mess up the most right here. Or would it be better that we go like this, and I change the subtract sign to plus a negative 1 or something? I don't know. And so a negative times a positive is a negative times a negative is a positive. I don't know. 3x squared, these ones, minus 2x squared is x squared. Then you got a 2x after. You got plus 1. And you got this 2x plus 2 at the bottom. The top can be factored out. What are the numbers for the top? X plus 1 and x plus 1. What's the GCF at the bottom? 2? Yes? What's left over inside? X plus 1. What can we do? Cancel out a set at the top that's equal to the same set at the bottom. So then the answer is x plus 1 over 2. And put parentheses around it. That's the answer right there. All right. All that for this. This is what we really need to know how to do, is to solve rational equations. So here we go. Does anybody know how to solve this already? Does anybody know how to solve it? Anybody know how to solve it already? Say something. What would you do? What would you do without me teaching it? Nobody's. Say loud.
Simplify and then set it to 0.
Mm-hmm. Have you guys heard of cross multiply? That's a method that people use, but I'm going to show you another method after that. But let's go ahead and do cross multiply because people like cross multiplying. So let me go ahead and cross multiply. Okay? 3 times x, and I don't know why I'm going this way first. 3 times x, because I just want to go like this. 3x. Bring down the equal sign. Bring down the equal sign. And then multiply it the other way because it's a cross, no? And then you're multiplying 1 times x is x. 1 times 4 is 4. And then I want to just solve this equation like this by minusing x. So 3x minus x is 2x is equal to 4 divided by 2, and x equals 2. Yes, that's called cross multiplying method. Here's another method. I'm going to present to you another method. And you tell me which one do you prefer. I don't care. I don't care which one you prefer. Here we go. I'm going to just do it differently. I'm going to approach it as I want a common denominator. Okay? Here we go. I want to have common denominators. So what is here that is missing here? What is here that is missing here? Of course, everybody will be saying, you're missing plus 4. So go ahead and put plus 4. Wrong. That's why I'm like, I'm going to ask it again. And can you please, everybody, say, you're missing the set. You're missing the factor. Say the set, I guess. So I want a common denominator. So what is under the second fraction missing in the first one? Hey, what's under the second fraction that is missing in the first one? The set. I'm going to answer my own question. The set. I'm missing the set. What you do at the bottom, you do at the top. What's under the first fraction that is missing in the second fraction? The x. Now this one's just x. Now, do I have a common denominator? Yes, I do. Now, this is where people, please don't mess it up. The difference between this problem and all the other ones we were doing is that in here we have a what? We have what? An equation. And only because it's an equation, I can go ahead and do this. When you have a common denominator. So now I'm going to be left off with x. 1 times x is x, 1 plus 4. So x plus 4 is equal to 3x. And then I minus x. So 4 is equal to 2x, x equal to 2. Yeah? So now I'm giving you 2 options here. There's 2 ways of doing this. You can cross multiply. Or do the other one. Let me slow down then on this one. Copy it down. Let's go. I have 23, 13 minutes? Yeah, that's enough. All right. You be the judge on which one do you think is the method to do. So let's go ahead and do that cross multiply first, no? Let's do it. Judge. And let me even go step by step. Let me just write it down next to it because some people need to see it. This is a set. which is still a difference of squares, but let's go ahead and write it down like that. And then I'm going to go this other way, going like this. So I'm going to go 15, that's called cross multiply, 2x minus 2. Good? Everybody good with this? And now we can distribute here and then distribute there, all right? So this is going to be what? 5x squared minus 5 equals 30x minus 30. So it became a quadratic equation. So we should set it equal to 0. Somebody said set it equal to 0. But in this one, just a quadratic equation, definitely let's set it equal to 0. Minus 30x plus 30 plus 30. So cancel, cancel. So this is going to be 5x squared minus 30x plus 25. Can I just like factor out a 5 and or just divide everything by 5? And yeah, let's divide everything by 5. So if I divide, do it in your head. If you divide everything by 5, you're going to have what? X squared what? I just want to get rid of that 5. So we can factor it. So what if I divide, let me write it out. Divided by 5 everything. So then if I divide everything by 5, because I don't want to see this 5, and you can't go ahead and divide 5 divided by 5, x squared, and this is going to be what? Minus 6x, and this is going to be what? Plus 5? And we can go ahead and do, we can do the x, or we can factor this. X and x, what are the numbers here? Wouldn't it be negative 5 and negative 1? Yes, yes. Because a negative times a negative is a positive 5, negative 5x, and negative 1x is negative 6x. That's what you really need to know. And so the answers are going to be what? X equal to what? 5 and x equal to what? X equal to 1. All right. Easy enough, no? Let me show you now the other way. This is for people that really understand algebra and see connections. I want to do where I want to have a common denominator here. Let's see if we can have a common denominator between these two here. What's the GCF? For this? 2. What's left inside? What's left inside? Isn't that a difference of squares? That a difference of squares? There's going to be what? X plus X. Let's match up the common denominator. So now, what is under the first one missing in the second over here? 2, and a 2. Now, what's in the second one missing in the first one? In the denominator, x plus 1, isn't it? X plus 1. What you do at the bottom, you do at the top. Only because this is an equation, and now I have a common denominator, what am I going to do to the bottom of the equation? So this top is going to become 5x plus 5, and this is going to become 30. So now I can solve this by subtracting 5, and so I'm going to get 5x equals 25, meaning that x is equal to 5. So now, your question maybe, if you have why does this one only have one solution and this one has 2 solutions? Which one is correct? The first method or the second method? They're both correct, but this one, is this an actual solution? Is x equal to 1 a solution? Because if I plug in x equal to 1 in here, if I plug it in here, what is 2 times 1? And what is 2 minus 2? Can you divide by 0? That is a sin in mathematics. Nobody knows. Einstein doesn't know. Nobody knows. I'm gonna know. This is not an answer. So the only answer was 5. Uh, Eight minutes. Which one do you guys want to do? I'm going to finish this. First method or second method? First method or second method? I'm just going to do it. X plus 4, x minus 4. This one's missing x plus 4. This is missing x plus 4. X plus 4. Now I have a common denominator. Yep. X minus 6. Negative 4x minus 16. Move it over here. 5x equals plus 6 over there. That's going to be negative 10. X equals negative 2. I just went really fast, but you get the point. Yeah. Yeah, get it? You could do the cross multiplying if you want to, but you're going to have to check if one of them maybe is not a solution. And we are done for today.